All right, let's start with the next exercise. Now, before going there, uh, let's see what we have learned so far. So these are the three ways to solve a problem that we have learned: for loop, conditional statement, and vectorization. And these are the built-in functions that we have learned so far. And this is something that you have in your arsenal so far. And these will actually come really handy to solve a problem. Now, if you're actually finding these lectures a bit too much or a lot of things actually provided in a single lecture, so just try to take it slow. That's why I'm actually separating this video one by one so that you can actually, instead of creating a 2 hours or 3 hours long video, I'm just separating with this 15 or 20 minutes video so that you can watch one video at a time, practice a little bit by yourself, then move to the next one, and so that you can actually learn properly. Okay. Now, so far we have solved three problems, and before moving to that, there are some additional exercises also given here. Okay, you can solve those things. You should solve those things. And before going to the next problem, try to solve this one, exercise 01. I provide these files. Okay, the more you solve, the more you will see that these things that we are actually trying to do, this will actually become very handy. This will actually become very easy. And one other thing is that before actually when you actually try to solve a problem, and don't think of it as something complicated or something complex. Okay, try to have some fun solving this thing. Okay, if you actually have some fun working on these things, you'll see that programming is one of the most interesting things to work on. Okay, even now, okay, sometimes when I actually feel a bit down, I just go to a platform like LeetCode or Codia or something like that, and just try to solve some problems. And solving problems actually really helps me enjoy the time. Okay, so this is a very nice thing to do. So let's move on to the next exercise. So this is our exercise 4. So, now here we have, this is our problem statement. Now this is a table containing the number of students in different departments in different universities. So I have a matrix like this. Okay, now um, so far you already know that we cannot actually use this heterogeneous data type in a single array. So in a single matrix, I cannot actually put this CSC or 120 in a single matrix. So I will only work with these numeric portions at a time. Okay, later on I will introduce you to table data type. Okay, there is another data type that is called table. Okay, or if you actually familiar with C programming or Python, okay, there is something that is called hash table. Okay, or in Python we call it dictionary. That kind of thing is something that is called table in MATLAB. If I get some time, I will try to introduce it later. So don't worry about it now. We just work with matrix or simple array for now. Okay, so here we have this data. Okay, so in BUET, CSC number of CSC students is 120, number of table students is 180, and so on. And one other thing, interesting thing here is that is called NaN. Now none, okay, actually means not a number. This is the abbreviated form, not a number, NaN. It actually means that when you have, like for example in RUET and C, that means civil department, I have put there none. It is arbitrary data. That means C department does not exist in RUET. Okay, so the purpose of none is, if I put 0 here, that means that department has 0 student. But now that is not the proper way to represent. If I want to say that for example architecture department is not here in IT, instead of putting 0, I'll put none. That will actually represent that this does not exist for this IT. Okay, that's the purpose of NaN, or not a number, or something that is not available. So let's copy. Okay, just copy this portion. Copy this portion. Okay, let's copy it and come here. Let's put it in a matrix called data. I have to put this bracket option, then the data, then bracket close. Okay, so this is our data. So as you can see, in our data, this is 1 2 3 4 5 6 7 7 by 5 matrix, and there are some none. Okay, capital N A N. Now previously you are introduced to length function. Now in MATLAB, when you have a matrix, I want to know what are the number of rows and what are the number of columns. We can do this by writing this size function. So size function actually gives this 1 by 2 array. So 7 is the number of rows and 5 is the number of columns. Okay, so we can also write this like this way: r comma c is equals to size of data. So now r, that is the row number, is containing this 7 value, c is containing this 5 value. Okay, you can separate it this way. You can already also actually put it in a single variable. That's okay. So we have learned a new function, so let's keep it. Okay, TikTok, then I have size. Okay, size. Okay, now let's go back here. So this is the size of our data. Now what is the first question? So this is the, so what is the total number of students in each university? So the first question says, what is the total number of student in each of this university? That means I want the sum of each of this column. So if you remember from our lecture 1, I said when you are actually operating, or when you are actually operating in MATLAB, everything is done column wise. So if I just write a function like this way, sum of our data, it should give me the summation, column wise summation, and sum is a function we have already learned here. If you see, this is sum. So always keep them and memorize these things. Okay, it will actually come really handy later. Sum. But now this is a problem. The problem is with this none. Okay? MATLAB by default doesn't know what to do with the none. So when I am actually summing this, all of these elements, if I have a none, it will just put out the none. It cannot sum. You can think of it like infinity. Okay, infinity means you cannot sum anything with the infinity. So none is like the opposite of infinity, something like that. So we have to do something so that this does not actually happen. So what to do about it? Okay, so let's actually write it here. So before I actually go show you how to actually what to do about it, I want to show you if I was not there, how you can actually find the solution. Okay, you are facing this problem. Think of it. You are facing this problem. Where to find the solution to this? So what you will do? Use this documentation, and learning how to use the documentation is actually very important. That's why I'm showing you or creating all these videos so that you can actually learn how to use MATLAB by yourself, and that's the purpose actually. Okay, there are thousands of problems. I can actually show you everything. So I want to teach you how to learn these things by yourself. So here you can see I have the syntaxes, some of it that we are trying to do. And if you go here in the last line, you can see there is something interesting. Sum, something, then none flag. And this is something actually catches our eye. So let's go to the description and see what it is written here. This actually specifies whether to include or omit none, and that's what we want to do. We don't want to include the none, we just want to omit the none. So what is the syntax for that? This is the syntax: sum a of a comma omit none. So if I write this omit none option, it will just ignore the none and perform our task. So let's see whether it does the function. So let's write it here. So p1 is equals to sum of our data but comma omit none. Okay, now let's run this. Now you see, now it is actually providing me the data. Okay, this is the data, so it is no longer none, it is actually providing the data. You can actually check, for example, this was our original data: 120, 120, 240, then 320, 400, 450, and 500. So this is correct. Okay, so it is just ignore the none. Okay, that's why I have written this omit none, another parameter. So I hope it is clear. So this is the first question is answered. What is the total number of students in each university? So this is the answer. So BUET has 835 students, then it is probably CUET or KUET, whatever. IT has 250 students and so on. Okay, let's go to the next question. So it is asking, what is the total number of students in all the 5 universities combined? So it is asking me what is the total number of students in all of those things combined. So I want to sum of all the elements of the matrix. Okay. So One thing we can do, we can just sum through this array. That will give me the output. Okay, right? I can, if I just sum T1, okay, sum of T1 will give me the answer. That is the correct answer, 2805. Okay, and there is another way. If I want to do it separately, if you remember, task 02, so T2 is equals to, you can do it, that's completely fine. We can write sum of T1, that's one way. Okay, and we can write it another way, T2 version 2, that is equals to, we know we can use sum of data comma all, if you remember. Okay, you can see the documentation if you want. Here you have this all option. This all option computes the sum of all the elements. Okay, now this syntax is valid for MATLAB version 2018b or later. So latest version, actually this is actually applied to the latest version. So if you're using something before than that, it may not be available. So let's start. Let's see. Now if we run this, it will provide me an error. Can you tell me why? Now, so it is not error actually. It is actually providing the none, because I have not written the omit none option. So we have to write the omit none option. And for actually, although it is not suggested, but you can just write O. Okay, this is the first letter of omit none. So it will automatically understand it as omit none, because I would not suggest you to use that, but I will use it multiple times. I don't want to write every time. So for now, I'll just write omit none, so make it clear. But after you actually practice lots of programs, you will see it will actually become very clear. But at first, I will suggest to write omit none full, so that you can actually remember what you were actually trying to do. So both are actually giving me the same answer. So this is actually correct. Okay. So I hope it is clear now. So we have solved the first two questions. Now, what is the total number of CC students in all 5 universities? So it is asking me what is the total number of CC students. So this one. So it is asking me the sum over all the elements in the first row. Okay. So if you remember from this right here, task 03, in your previous one, so this is our data. This was our data. I want to sum the first row. So I have to first extract the first row. Okay. I can just extract the first row, then sum over the elements. Okay. If you remember from your previous one, let's say row 1 is equals to our data of first row. So first row 1, then all the columns, then this column. Okay. We have used this in the previous one. Okay. And let me just suppress this output so that output. So now we have this first row. We already have this one. Okay. And I just want to sum over these things. So our T3 is sum of row 1. Okay. So this is the summation 460, 120, 120, 240, 340, 380, then 460. Okay. So our task 3 is also done. Let's go here. So what is the total number of CSE students? Similarly, you can do it for any or any of them, any else of them. Okay. Now let's go to the next question. It is saying that how many students are there in the civil department? How many students are there in the civil department of Kuwait? Not the total students, but the what is the civil department of Kuwait? So I want this one. Okay. So Kuwait actually stands for 3. So I want to find this element. Okay. Right. So this is the 4th row, 3rd column. So now, for now, we are not using this array for civil. So how to access this element? So just imagine that you already know the index. Just think of it like you already know the index. So how to access a particular element? Okay. So I want to access 4th column, 3rd element. So I can just write our data 4,3. Okay. It will automatically give 150. So this is, I am using the subscript option to extract any element. Similarly, I can use data 4,4. What it will give? 4th row. Okay. 4th row, that means civil department is student of Kuwait. So that is 80. So that is 80. This way we can actually access any single element at a time using the subscript option in matrix. Instead of using linear index, we don't actually use linear index for matrix. We can use it, but it actually makes it complicated. So subscript actually makes it more easier representation for matrix type of data. So we'll use this subscript option. Okay. So I believe it is clear now for now. So let's go to the next question. Which department or departments of each university has the highest number of students? Now try to concentrate now. This is actually, I am asking that which department or departments of each university has the highest number of students. That means in this column, which departments has the highest number of students? So 195, this is the highest. Civil department. So GUET has, civil department has highest number of students. When you come to RUET, there are two departments, both CSE and EEE has the highest number of students. So 2. So maximum element can be 2 as well. Then I have this one, 150, 150, 153. So QUET has 3, EEE, ME, Civil. All of them has the highest number of students. And it has asked me to mark them by index for now. Index 32, the subscript. Okay. So I have to, so if I want to the maximum of QUET, I have to write 4, 1. For RUET, I have to write 1, 2, 2, 2. Okay, this way. Now how to do this? Okay, now if you actually went through the last few lectures, you have seen that we can actually use the for loop. Okay, we can use the for loop to find the maximum of each element, each column, using the for loop, using a for loop from 1 to this 5, and each time I'll calculate the maximum of each of this column. Okay, and see what are the maximum elements. Or we can use, more importantly, we can actually use our vectorized code, and that is the most interesting I have seen. So I am not going to write any more for loop anymore, because in MATLAB we actually try to avoid for loop, because if we want to write for loop, then I will be using C programming in MATLAB. Okay, MATLAB is built so that we don't have to write those kind of for loop. Okay, so let's do something like this. So I want to see the maximum of this second row, second column, for example. Say, so data of all the rows of 2. Okay, so let's name this thing, that will actually make it clear now. X is equals to data of auto. So these are the data, second row I have get. Now I need to do x is equals to maximum of x. That was the indexing, if you remember. That will give me 1, 1. Now I have to just find the index of these two using find of answer. So this is 1, 2. This is giving me the index, and this is for one single column. Okay, so you can try try to do it. Just pause the video and try to do it for other columns as well. So we can do it, but we have to do it for each of the column. Okay, so what we can do, we can write again, we can write a for loop, go through each of them and implement this vectorized loop for each of the column. Okay, but again, that is not actually the best approach. We can actually use the whole thing vectorized way. So that is most interesting. That is, our data is equals to maximum of our data. Let's see what does it give. Wow, let's say this was our data, and when I'm writing this line, a single line, data is equals to maximum of data, it is automatically giving the maximum of each of the column. So 120, 120. It is not considering this one for every row, every column. It is considering for each row, each column. So that is that's how MATLAB works. It is considering this maximum of this column. So this is the first column. The first column, this is 195. That is the maximum. For the second column, 120, 120. That's why these are 1. Then for the third column, 150, 150, 150. These three are 1. For everything, for fourth column, everyone is 80. So all of them are 1. Okay. So we can actually write. I can actually just use this one to actually solve this problem. That actually makes actually omits any use of for loop, and that's the best way. And that's actually pretty, I would say, pretty amazing what you can do with MATLAB. Okay, so let's write. Okay, that's 04. So we want to get this data. For now, let's try to get this data first. So let's name this as x is equals to our data is equals to maximum of data. Now, if we are actually having trouble understanding, let me actually make it a little bit clear. I think some of you might have some problem yet understanding. 2, 3, 4, 1, 6, 5, 1, 6, make it 5. Okay, and again 3, 1, 1. Let's make it 2. So this is our matrix for now. Let's think of it. This is our matrix. Okay. if you understood what we are doing, you can just skip this portion. Okay, I'm just trying to explain a little bit further. So first of all, say think of it, this is our data, a 3 by 3 matrix. Okay, this is our data. Now when you are writing that code like max of x, so think of it, this is x, so max of x, what it gets, so maximum of x, what does it give? It gives a, it will give you a column vector, sorry, one, it will give you a column vector, the maximum, sorry, it will give a row vector maximum of each of the columns. So it will give me 3 comma 6 comma 5. So that is what you are getting. Okay, so this is the output. So the code that we are going to write here, okay, x is equals to maximum of x, that we actually write, right? Data is equals to maximum of data. So the maximum of x means this is the maximum of x. So when you are writing this, it is doing, it is putting this 365, okay, like this, 3 comma 6 comma 5, okay. So it is actually putting this x and this maximum of x this way, then it is performing the task, this one, it is matching this one to this one, okay, then it is matching this one to this one, okay, and then it is actually matching this one to this one and giving me the logical indexing of a, so 0 then 0 then 1 and so on this way. Okay, so I hope it is clear now. Let's go back. So this is our data, original data, x is equals to data is equals to okay. So we have this one, okay, but in the question you can see we have to find the index. So if I actually write something like, if you remember, that is our T4, okay, T4 is equals to find x, it will give me, let's run it first. If I run it, so this is our output, this is the logical array that we actually find, and this is the one, this is 1 2 3 4 4, then 5 6 7 8, 8 is given, then 9 is given, all of them are given, but the linear index are given. Understand, these are the index, linear index for one, but using this it is actually difficult for us to make visualization of the data. Okay, we can use it, but in the question I have asked you to use this one in particular, 3,2. Okay, I want the subscript. Okay, I want the subscript, not the linear index. So what to do about it? Let's see what can I do about it. Let's find. If you feel this it is too much, just try to take a pause and see it again. It will become clear. You will see here there is another option. We are using this option for now. K is equals to find x. That was what we are actually trying to do. But it also have this another option, row comma column is equals to find. That means we can actually automatically get the row and column if I just write it in a different way. So instead of that, if we write something like this, R comma C is equals to find x. Okay, let's see what it gives. Run it. Now you can see I get this one. Okay, R and C as a column vector. Okay, let's do something. Let's just change it. It will make it more sense. So 4,1, and this is our data. Okay, so this was the data. So when you have 4,1, that is the maximum of this element, right? Then 1,2, first row second column, that is the maximum of this column. 2,2, that is the maximum of this column. 2,3, so this is like a 1-by-1 mapping. Okay, in serial this is actually mapped all together. Okay, and we can actually also join this together as a tuple like this. If you're actually familiar with tuple, we can actually write this like this way. One, so it should be like 4,1, then comma 1,2, then comma 2,2. Okay, we can actually join this thing together using, there are some function like array fun, self fun, but I don't want to go to so much details now, so make it I try to keep it simple. So I hope that this is okay. If you just can come to this portion, I believe that is already enough for you for now. So this is our question 4. So this was our task 4. Let me keep it here. Let's comment this portion out. Okay. Now let's go to the question again. So if you don't understand, just pause the video and rewind the video, watch it again. I believe it will be very clear. I hope. Okay. So this was our question. So this was our task 5. Now, the sixth question is said that which department of which university has the highest number of students? Understand? It is asking that of this whole matrix, which department of which university has the highest number of students? So I want to find the maximum of this whole university. So what we can do, if you remember, this was our data 5. Okay. So this is our data. So I want to find maximum of our data. But if I just write data, it will give me the maximum column wise. But what I want to do, I want to find all. Okay. Okay. Now this will also give you an error if you remember. Matrix dimension must agree. Why? Because I have to put something like this. Okay. So now we have something like 195. So that is the maximum element. Okay. So of this whole matrix, that is the maximum element. If you try to find the minimum of the data, so the minimum of the data is 30. So 30 is the lowest number of students in any department of all the universities. Okay. But in the question, okay, I don't have to, I have to find which department. So I have to find the index of the department, or more importantly, the subscript of the department which has the highest number of students. So how to do this? How to do this? If you remember, we can write something like m comma idx, okay, is equals to maximum of data comma all. Okay, if you remember this way, we can actually get the value as well as the data as well as the index as well. But still, there is one thing that will actually give you an error. I have not specified the linear option, so I have to specify here linear. Okay, so 195, and it is actually giving me this index 4. Okay, so it is automatically giving me the index 4, but this is the linear index. It is not providing the subscript. It is providing me the linear index. Okay, now so let's copy it here. We have it more. Task 06. Okay, now actually before finishing wrapping this question, I want to show you another way. So one thing that is actually coming again and again. Okay, so I have something that is called linear index. Okay, and I have something called subscript. And when you are actually using matrix, these two will come again and again. So if there is a way to interchange between these two, that will make things very convenient. Okay, so if there is any way to interchange between these two, and there is actually a way to interchange, so how can I do that? So this is our index. So we can do something like, I want the output. I want the output subscripts. So if I want subscripts, that means I want two things: the row index and the column index. Okay, and the column. So when you actually want two output, you should write this way. Otherwise, it will not actually provide the full output. So there is a built-in function that is called ind to subscript. That means that stands for index to subscripts. So if I actually write it here, you can see it will automatically give you this help. Okay, it will give you a hint how to write the function. It is written here size. That means I have to give the size of our original matrix, that is the size of our data. And the second thing that is asking, the index. What is the index? IDX was the index. If I write it here, as you can see, this is the fourth row and first column, and 195 is actually studying the fourth row and first column. So using this way, index to subscript, we can actually get the row and column of our original data. Okay, so we can actually convert this way. So I believe it is clear. Let's write row and column. So row and column, index to subscript. So this will actually give you the subscript of your output. Okay, so we have learned anything, one new thing that is very important. 112 is equals to index to subscript. Okay, and there is actually something similar if we want to do the opposite way, subscript to indices, actually you can also try it. Okay. Subscript to indices, and you just go through the documentation and see how we can actually do it. Okay, try it first, and I hope it will be clear. So this was our sixth question, and so this was our sixth question, and the last question was try to visualize the data. So if you remember, okay, uh, where is our data? So this is our data. So right, double click on it. So this is our data. So if I want to visualize something, say for example, if I want to visualize this column, okay, visualize this column, I'll go to plots and you will see different options. If I this plot, per plot, so it will show me the plot. That is, the first one is 40, the second one is 80. So I can easily say the second, that is the probably the TPL department, has the highest number of students, and this one, which is probably BTM, has the lowest number of students, and 5, 6 are empty. That means they are not available. Okay, so this is one example bar plot. We can also do something like, say, let's try this pie plot. No, pie plot will not actually happen. So, so let's try this one for pie plot. So the error that actually, this is for Buet, okay, and the error that actually that showed here is because all data must be finite. So it actually contains some non-value. Okay, now this is actually something, this process is called data cleansing. If you have something like none, you can actually change it to some other values like 0, so that our pie chart actually can provide some value. So don't worry about it for now. Okay, we'll learn those things later, or you will learn those things later. I don't think I'll have the time to show you those things. So this is what we call a pie chart. Okay, so it is giving me the percentage of different universities. Here insert, there is, you can actually insert something like X level, Y level, and title and legend. Okay, different things can be inserted. I will show those things later on. So this is showing me. Okay, so data 1, that was the first 120. Data 1 is actually consists of 14%. Data 2, this one actually consists 22%, because this is 180. Data 3 is 18%, and data 7 like 50, that is a small 6%. So this way we can actually make much more sense to the data using this visualization techniques. And we're actually using this graphical user interface to actually solve this. We are not writing any function in particular. Okay, so try it a little bit by yourself. Try for different columns, different rows. You can actually try some of this as well. Not all of them you can actually so you can use a stem plot. This is something, a stem plot is something you will learn when you are actually using taking the signal processing course. Okay, I don't think you have it is in 3.1 probably. So I hope it is clear. So we can use this plots option to actually plot by using the graphical user interface. Okay, we don't have to write this code. In a couple weeks later, I will show you how to actually write this code by yourself, how to plot by yourself. So I think this is clear. Now I have not put the output here, so I think that's done.